Hello everyone. Um, I am Foupouapegnigni Moihamette, a PhD student in the University of Yaoundé. I'm working with Wilfried Pokam. Our presentation is entitled Influence of Indian Ocean Dipole on Central Africa Rainfall. And this presentation will follow the present outline. The regional climate within Central Africa is modulated and influenced by adjacent Atlantic Ocean and Indian Ocean, where variability in sea surface temperature can influence moisture availability and moisture advection. Due to its proximity with Central Africa region, several studies have focused on the Atlantic influence. Recently, Dyer et al. 2070 found that Indian Ocean is a major oceanic moisture source of Central Africa rainfall. In the context of global warming, increase in sea surface temperature have been observed in tropical ocean with highest rate in Indian Ocean. Such a pattern will increase the frequency and intensity of IOG. In the same time, several studies project an increase in Central Africa rainfall due to the climate change. And this allows us to evaluate the influence which can have the Indian Ocean on the Central Africa rainfall in the present to be more informed what will be the consequence in a global warming. This presentation have two objectives. First, we will investigate the response of Central African rainfall to Indian Ocean events, and we will examine the contribution of regional atmospheric circulation features in modulating the nature of Indian Ocean dipole influence on Central Africa. Figure 1 shows a 30-year running correlation coefficient between Central Africa and GMI, which is the index used to monitoring the variability and the intensity of Indian Ocean dipole. And from figure 1, we can observe that IOG and Central African rainfall relationship is positive and time varying. This relationship increased only after 1980 and is statistically significant from 1990, regardless of the rainfall data used. And from 1980 to 2018, we record 8 positive IOG and 7 negative IOG. Here, in figure 2 and figure 3, we present respectively the rainfall variability associated with the two phases of IOG. From figure 1, you observe that during negative IOG, Central Africa experienced a decrease in rainfall from September to December, while during the positive IOG event, we have an increase in Central Africa rainfall from September to December. Next, we investigate the response of vertically integrated moisture flux to the two-phase of IOG, as several studies highlight the direct influence that have moisture flux anomaly in rainfall variability. Uh, in during positive IOG, you observe that the moisture flux transport is associated, or the increase in Central Africa rainfall during positive IOG, yes, is associated with moisture convergence, as we can observe in figure. And we have an opposite pattern during negative IOG. And by represent the longitude high cross section over Central Africa of zonal moisture flux, we observe that there are two centers of moisture transport, one over Indian Ocean, as you can observe here, and another one over the Central Africa. Inflow is strongest in the lowest troposphere over ocean, while it is strongest in the mid-troposphere over Central Africa. To understand what are the moisture drivers in over ocean and Central Africa in the mid-troposphere, we present in figure 6 the circulation at the mid-troposphere, where geopotential I is changing, is screen function, the red contour, and wind vector. We can observe that during positive IOG, September, which is the month during which the Indian summer moisture is still present, have a cyclonic circulation over the Indian landmass, which is the main moisture driver over the Indian Ocean. And during this month, circulation over Indian Ocean is dominated by westerly wind. But from October to December, with the disappearing of this cyclonic circulation, the circulation over the equatorial Indian Ocean become progressively easterly, which is favoring for moisture transport towards Central Africa, and then to increase the availability of moisture flux, and then increase rainfall over Central Africa. We have an opposite pattern during the negative Indian Ocean. During the negative ocean, as we can observe, the circulation over Indian Ocean is dominated by the cyclonic circulation, which strengthen the climatological westerly wind over the Indian Ocean. And over the Central Africa, during positive IOG, we can observe a weakening of the African earthly jet, which is the main driver of moisture flux transport over Central Africa. And we can also observe that from November to December, from the positive IOG phase, contour over the continent, which materialize the Saharan high, shift westward during positive Indian Ocean, which is not the case during the negative Indian and during the negative IOG. And this have the consequence of this is that of that is the consequence of this is that in during the positive IOG, we have a weakening of the African SDZ north component and a strengthening of this African SDZ during the negative IOG phase, as we can observe in figure 7. The schematic diagram of physical process of how IOG influence regional circulation feature of West Africa during both PIOG and negative IOG event is the result of a publication that you can visit in the climate dynamic page following the present link. Our current work consists to assess the ability of synopsis models to simulate IOG Central Africa rainfall teleconnection and investigate the atmospheric dynamics associated with the ability of each model to simulate the IOG Central Africa rainfall teleconnection. In figures 8, we present biases of SST and low-level wind over Indian Ocean from ERA 5 for semi-6 models. And we can observe that most models show a warm SST biases in the Eastern Atlantic Ocean and along the East African coast, and cold SST biases over the Central and the Eastern Indian Ocean. In figure 9, we present the rainfall anomaly simulated by each model during positive IOG and negative IOG, and the associated vertical moisture freeze anomaly during positive IOG is present in figure 10 to understand biases of rainfall variability during positive IOG events. And for the next step, we will assess the fidelity of historical data from EERIE model simulation to produce the IOG Central African rainfall teleconnection and evaluated the R value of high resolution EERIE simulation compared to lower resolution global climate model, especially semi model. Thank you and see you next time.